Music theory with OneNote. Traveling in the negative direction over an octave. Best method for the scale degree interval system. Remembering once again that the scale degree interval system is not the best system, but is the most used system. So we're talking about the best method for the worst, but most used system. In a future presentation, we'll talk about going in the negative direction over an octave using the best method for the best but least used system, that being the modal distance system. But we first have to lay the foundation. So get ready and some coffee, because although we're only playing with one note, it's a beautiful note. You're not required to, but if you have access to it and would like to follow along, we're currently in the OneNote file of Modal Node System, MNS Presentation 1251, OneNote, negative over an octave, best method for scale degree interval system. We have our presentations here, which we plan on adding plenty more to shortly. Also noting, within this OneNote presentation, we could spend all of our time on the music theory side of things. However, we also have another presentation by a similar number and name where we build these tables in Excel, practicing our Excel skills, our music skills, and just table visualization all at the same time. Looking once again at our interval notation, which is our distance notation, and it's also our directionality notation, which is where the current system basically falls apart because it doesn't have a very good way to indicate directionality. In other words, the way the current intervals are basically structured are as though if you think of a note number line, we're always going infinitely to the right or up in pitch. Or if you think about a clock face, we're always going clockwise around the clock face. But obviously, in reality, directionality is a thing. We could go to the right, we could go backwards to the left. We could go clockwise around the clock face or racetrack, and counterclockwise around the clock face or racetrack. We've seen in prior presentations that when we start to go counterclockwise, the current interval system kind of falls apart. Now we're going to go counterclockwise past an interval counterclockwise, and the system was already falling apart, and now we're adding the other factor, the other dimension of going over an octave, which means it's going to even fall apart further. Think about how we can deal with that with the current tools that we have, and then we'll introduce the new tools with a measurement method, which would make more sense. Let's first remember our analogy, first remembering the mindset that we want in order to map out the fretboard. That being the fretboard is the territory, like the globe, and it has 7 continent or destination locations like the globe, and it has 5 oceans, which we're going to say are the pass-through locations to get to the destination locations, which are analogous to the continents. Our head is above the fretboard, above this low or heavy E string, the one closest to the ceiling. As we look down on the fretboard, we notice that it rotates around like the planet rotates around. We give it 12 degrees of rotation, calling those the notes in the musical alphabet. We're typically working on the 4th degree of rotation, that being the collection of notes, the continents, if you will, that are organized through the 4th degree of rotation, the key of C. So that's the 7 notes. Once we note that, then I no longer want to name all of the notes on the fretboard, because that would be like naming all of the positions of the planet from the perspective of space as the planet is rotating around in a circle. No, what I want to do is identify the view of rotation. Then I want to name the continents based on that perspective, which is basically what the Nashville number system does. We're just adding now the actual modes. The Nashville number system is the modal system. So 1 is an Ionian, the 4 is the Lydian, the 3 is the Phrygian, the 6 is the Aeolian, and so forth. If we went from the 4 to the 5, C to C sharp to D sharp, the whole thing would shift forward like the continents going around in a circle. Therefore, all of the intervals are the same. So that's going to be our concept. Now, the problem, of course, is that the scale degree system, it kind of forces us out of looking at the system from a continent to continent location. It wants us to name every point as though the globe was spinning around, and I'm going to name every position from every point as it spins around in a circle. That's not the most efficient way to do it. Or it also wants us to rename the continents within the system, the 7 continents, based on which one we're starting from, which would be like making a new map quest every time I'd go from a different order of locations. You don't need to do that. So that means that as we're looking at the current interval system, we want to keep that in mind. Now, if I'm measuring my distance, remember that it's not as hard as a map, because I don't have to go left, I don't have to go right. It's a racetrack. I can go clockwise or I can go counterclockwise. And I can count it using 2 different measuring methods in principle. One would be continent by continent in our analogy. The other would be continent and ocean in our analogy. Now, if I go continent to continent, that's where the current system is messed up. Because if I went from this 2, South Africa, to 3, 4, it would be 2 continents up, 1, 2 continents up, right? This is South America, but they want to make that the 1, so it's the 1, 2, 3. So notice those 2 methods are really using the same measurement tool. That would be like using a ruler, but you put the ruler on the first continent instead of after the first continent. They're both using the same measurement distances. They just messed up the first unit of measure, right? And so those are the 2 methods that we can use, or we can use the continents and the oceans. So that would be 1, 2, 3 up. So that's going to be the idea, but we can also go backwards. So if I go backwards, it would be 1, 2, 3, 4, 5, 6 modal half steps backwards, which you would think similarly, if I make that the 1 and go counterclockwise, it would be 1, 2, 3, 4, 5, 6, 7 backwards. Problem is that it became apparent that negative scale degrees don't work, because then you would have to rename all the scale degrees in negative order, and you can't easily transpose it to the positive scale degrees because you started on the wrong number, right? So when we go in the negative direction, it totally falls apart. So we saw that before. Now we're adding the added problem of, what if I imagine I'm going around the track and then to here? So instead of going 1, 2 back to here, I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9 back here, which would be the 10th scale degree in the negative direction. Well, we don't have scale degrees, right? So that becomes a problem, because normally what happens on these distances is they actually drop the units. They drop like the note names, and then they use the scale degrees, and the scale degrees are off by 1. Right? So then they couldn't use the scale degrees going in the negative direction because they don't line up. You can't subtract 7 easily and get to the forward position. And so we have a problem going in the negative direction, and now we're going in the negative direction over an octave, which is usually indicated if you drop the note names by having what we call compound scale degrees, right? You would call that the negative 10th. If I was going forward, I would call it like a 10th, right? But now I'm going backwards, and we don't have scale degrees. So what's the solution to this using the current system? The solution is you need to say the notes for the distance, because that'll help you to identify how far back you're going. Let me show you what I mean. So we have this same situation here. We've got our notes. We pick the key of C, which if I start on the C, whole step, half step, whole step, half step. Here's the 7 notes in our musical alphabet that we're going to be using. And remember that we could have started that from any other note, and all of the distances would be the same relative to that position. So now we're saying, okay, all of our intervals going forward, if I was just going in a note number line left to right, there would only be 11 distances from the first point, from any point. That's fine. But you can also imagine that, remember, there's a note number line perspective and there's a racetrack perspective. In reality, those two things are combined, because what's happening is you have a spiral that's going upwards, which has directionality both up and down, or left and right, and it has a circular dimension to it. So we can't really envision that with our minds too easily, therefore we have to kind of like pick one. So if I go above 12, I have to indicate, that I went another octave up. Now again, you don't have to. Like if I say it's a major third, for example, then what does that mean? That usually means that it's going to be a 4 note away major third, as we can see up here, a 4 note away major third. But what if I go an octave up? It would be 4 plus 12. So you could use scale degrees if you're going in the clockwise direction. I could go from 7 and then 8, 9, 10. It would be a major tenth. So you have that scale degree notation, but most people don't actually do that, particularly on the guitar, because we want to see the similarities of where all the flavor of the major thirds are. So my recommendation is to say, well, let's keep using the major third like most people kind of do, and then actually say the distance. So it's a 4-note away plus an octave, or a 4-note away plus 12, or a 16-note away major third. That gives you the flavor of a major third, and it gives you the actual distance instead of calling this a major tenth. Now, the reason a textbook doesn't do that is because they don't say the notes. They just drop the notes entirely. And if you drop the notes entirely, then if you just say it's a major third, you've lost the dimension of over an octave. That would be like if we have our planet analogy, time is that other dimension, right? So you have the locations left, right, and then time could be the next dimension. I won't get into that, but in any case, so the only way to do that is to call it a major 10 then. But again, that's possibly more confusing. The better thing to do again would be adding the distance. Now, when I go in the negative direction, you will recall that everything falls apart, because if I go negative 1 step in the reverse direction, counterclockwise on a racetrack, then you would think that would be a negative 2nd scale degree. But we don't do negative 2nd scale degrees. Why? Because the scale degrees would be all messed up, because they should have started on 0, so they don't make sense going backwards. So what do we do? We have to use the inverse or something like that, or we have to just basically memorize that the negative direction, I can use the same name to go backwards. So in other words, the way I would recommend seeing it is if I go back 1 step. So in other words, if I'm going back from like this Ionian to the Locrian, then you would have to say it as though you're going forward 11 steps, but I'm really going backwards, right? So I need to somehow be able to indicate that I'm going down in pitch or backwards a step. I'm not going forward 11, right? Because if you saw it as a track, you can go clockwise, 12 minus 1 would be 11, or you can go backwards 1. That's great if you think about a racetrack. However, there's also the third dimension of directionality that's being lost if you do that. So what I would recommend then is saying, we're going to say it's a negative 1. How do I know what the interval name should be? You have to take the inverse. 12 minus 1 would be 11, and I know 11 would be a major 7. So I would suggest adding that in your mental framework. The major 7 could go up 11, or it can go negative 1. And I would say that when I say the interval, it's a negative 1 note away major third, right? If I go negative 2 back, 12 minus 2 would be 10 forward. So instead of calling it a negative, 2nd half step backwards scale degree, which we don't know, and most people don't really do that, I'd have to say something like it's a negative, it's a negative minor 7, right? Because it would be a minor 7 going forward. A negative 2 minor 7 gives me the directionality, gives me the flavor that is a minor 7, but it tells me where I'm measuring from, right? I'm measuring from the higher pitched note to the lower pitched note, not from the lower pitched note to the higher pitched note, right? So like if I went from this Ionian back to this Locrian, I could say, well, that interval is like the Locrian to the Ionian, but that's not what I'm trying to do. I'm trying to go from the Ionian back to the Locrian. So right, it's not a 1 note away from the Ionian. It's an 11 note away if I was to go forward clockwise. Sorry, it's not a 1 note away from the Locrian. It's an 11 note away if I was to go to the right around the circle from the Ionian, or it's 1 note back, from the Ionian, because I'm measuring from this point. I'm not measuring from this point. So that's where the problems come in. Now, so that's going to be the idea. We want to figure out then, using the current system, how can we add directionality? I think the best way to do it is to figure out the inverse distance and then the interval name for it, and then just name it would be a negative third, in this case, major 6, right? So that means the major 6 could be forward 9 or backwards 3. So then we can just extend that idea. If we start to use that idea, then we can extend that back over past an octave in the same way we did before. How do we deal with if I go negative 12 steps backwards? Now I've gone past an octave. So now we're going an octave backwards. So if you add the notes, then it doesn't become a problem. If you don't say the notes, it becomes a problem because you don't have scale degrees, right? There's nothing, I don't even know how exactly what the textbooks are going to even have a problem with that, right? Because it's like, there's no scale degrees. So how do I go backwards, past an octave? You can't have compound negative intervals because there is no negative scale degrees that most people use. So what do I recommend doing? I would say that you want to add a negative notes. So it'd be a negative 12 perfect first. So in other words, if I went back here 12 from let's just keep on working from here. I'd like to have one all the way on the thing, but if I went from here back 12, it would be negative 5 if I go up 1, negative 10, 11, 12. So negative 5, negative 10, 11, 12 in the negative direction, right? So that's going to be, or I can say it's a 0 if I stayed on the same note, and then a negative 12 octave, plus a negative 12 or minus a 12, however you want to see it. Let's see the next one up, which might make it a little bit clearer. So we're going to say, because the octaves sometimes are a little bit funny of an example. If I go negative 13 back, how would I figure that out? So if I go negative 13 back from here, let's go from here and say it's 5. I'm going lower in pitch, which is up high towards the ceiling when I go on the guitar. So it would be 5, 10, 11, 12, 13. So I would normally call that an IN, modal range, right? But we're going in the counterclockwise direction from the Ionian node. So if it's 13 back, how would I figure that? Well, I want to get the local distance, which would be under 12. So it would be 13 minus 12 would be negative 1 back. And then negative 1 back would be here, right? Negative 1 minus 12 would be 11 forward. So if I went 11 forward from this point, like if I was right here and I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, we get to here. So that would be 11 forward to the Locrian is going to be equal to 1 back. So that means the minor 7 could be going 11 forward, or minor 7 could be 1 back, or it could be any interval of 1 back. So I would call this a negative 1 minus 12, or negative 1 minus another octave in the negative direction, right? And so that's going to be a negative 13 minor 7. So that gives us the flavor, and then this gives us the directionality as well as the actual distance, showing that it's over an octave. So that means on a guitar, I can differentiate then going from this Ionian. I'm not just going to call it a major 7, right? If I went here to here, that's a major 7. Most people will also say that if you go here back to here, then that's going to be a major 7. But now I'm going in the negative direction, right? So I have to somehow deal with that directionality problem. Most people just use on the guitar shapes, and they just kind of memorize the shape. But then you're kind of losing the idea of what's actually happening from a directionality standpoint. All right, let's try another one. We're going to go just go back, and then say we go back 14. So if we go negative 14 back, this would be from a minor. Let's go from the Aeolian this time. We're going to go negative 14 back. So that's over 12 in the negative direction. So I went over an octave in the negative direction. So I'm going to say 14 minus 12 is 4 minus 2, which would be equivalent to going negative 2 back. That gets me to here, right? That would be like going negative 2 back. If I went negative 2 back, how many steps clockwise would I have to go to get to the same spot? 12 minus 2 would be 10 forward. That means we're looking at a 10 note away minor 7, could also be a negative 2 minor 7. So we're looking at a minor 7 distance. So I would say it's a negative 2 minus an octave. -2 minus another 12, or -14 minor 7. So that means if I went back, so really if I went back from here back 2, it'd be 1, 2. That would be an AX modal range. But now I want to go back 14. So maybe I can go 5 up here, because there's distance of 5 between the strings in the negative or lower pitch direction. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Right? So both of these could be called a minor 7, as could be going, in the forward direction, right? Like right here. But this would be going up 10. This would be going back 2. Both of them have a minor 7 from the perspective of the Aeolian, but this is -2 back minor 7. This is up forward 10 minor 7. And this is -2 minus an octave, or minus another 12 minor 7, right? So those, we have to somehow get that straight in our mind, which it seems like is not as easy as you would think. So let's go back another one. We have -15. So if I go back -15, then what would be the local distance? 15 minus 12 is 5 minus 2, 5, 4, 3. So it would be a -3 back. If I went -3 back, what in the counterclockwise direction, what would be the clockwise direction to get me in the same spot if I think about it as a racetrack? There's 12 degrees or 12 steps, so 12 minus 3 would be 9. And then I have to know that 9 forward would be a major 6. So that means that the major 6 could be 9 forward or -3 backwards. So, and it could also be -3 minus an octave, or -3 minus 12, or -15 backwards. So if I was on like this Ionian, then we can say, okay, I can go backwards 3, 1, 2, 3. That would get me to the Aeolian. So that's going to be a minor 6. I could go forward 9. So that would be like I can go 5, and this would be 10 up here because of the fault line, and then back to 9. That would be a 9 note away minor 6. This would be a -3 minor 6, but I want to go a -15 major 6, not a minor 6, major 6. So that would be, I could go between each string. Where did my cursor go? My cursor got lost. There it is. So I can go 5, 10, and then 11, 12, 13, 14, 15. See, so all of these are going from the Ionian node to the Aeolian node. We can call that always like a major 6, which is what most guitars do. We just start to learn that shape as a major 6, but then we don't really know how to count it. Or if we do, we can only count going upwards, right? When we start to go in the negative direction, it becomes a problem. And even if we figure that out, when we go in the negative direction and we go beyond an octave, it becomes a problem, because most people don't say the notes, and we don't even have scale degrees. Even if you knew what a compound interval was, you can't really say a compound interval going backwards, because nobody really uses negative scale degrees. So I would recommend that we're gonna use my solution is to say the notes that you're traveling, and that will give you powers that you have beyond what you've ever known before. So what if we go back 16? So if I go back 16, the local distance would be 16 minus 12, or 6 minus 2, which would be 4, -4. If I went back 4, then counterclockwise, what would be the clockwise distance on a racetrack or around the block? 12 minus 4 would be 8. And I have to know that 8 would be a minor 6. Therefore, I can either go forward 8 to be a minor 6, or backwards 4 to be a minor 6, or I could go backwards 4 plus an octave, or minus 12, right? Or backwards 16, a -16 minor 6. So let's start from an Aeolian node again here. Let's say we're on, let me pick one like in the middle. If I pick an Aeolian node, I could go forward 8 to be a minor 6. That would be like 5 here, and then 5, 6, 7, 8. So I would call that an AY modal range. Or I can go backwards 4 to be a minor 6. We can go 1, 2, 3, 4. That would be what I would call a negative 4 note away minor 6. Or I can go any interval backwards. There's only going to be like 2 around that I can go back on the guitar with, and we run out of space, but infinitely back in theory, back 16, right? So that would be negative 4 minus another 12. So I could go 5 notes here, 10, 11, 12, 13, 14, 15, 16. So note that most people will just learn this by saying, oh, I'm going from the A to the F, or I'm going from the Aeolian to the Lydian, or it's a 6-4, and I'm just going to memorize all those shapes and just call all of them a minor 6. But it would be a whole lot easier to understand that if you could actually prove that to yourself by counting it out and then being able to distinguish what it means, because it's not exactly the same, even though they're all going to be like minor 6s from a racetrack analogy. It's not from a note number line system. This one is within the octave going forward, the normal distance. This one's going negative compared to this one. You could take the inverse and measure it from here. Lydian going this way would be 1, 2, 3, 4 note away from the Lydian, which would be a major third. But I don't want to measure it from there. I'm measuring it from the Aeolian, which means it's 1, 2, 3, 4 backwards, which means I should have a name for going backwards, but I don't. So I have to call it the forward name, which is a major 6. But I'm going to say, no, it's a negative 4 major 6 because I'm going backwards. And if I go backwards over an octave, I need something to tell me that going to this Lydian is different than that Lydian, even though they're both basically minor 6s. And I keep on getting the major and minor mixed up. I apologize for that. Let's do the next one. All right, we're going to go to the next one. Let's see. So let's say we go back 17. So then we say, okay, well, what's the local distance? It would be 17 minus 12, 7 minus 2, 7, 6, 5 notes back. If I go 5 notes counterclockwise, what would be the clockwise direction if we go around the block? 12 minus 5 would be 7. I have to know that 7 would be a perfect fifth, and therefore the perfect fifth could go 7 forward or 5 backwards, or it can go negative 5 plus or minus another 12. So it's a negative 5 minus an octave, negative 5 minus 12, or negative 5 or negative 17, perfect fifth. So if we look at a perfect fifth, we can start on either one. Let's just go right in the middle with the Mixolydian here, and we go a perfect fifth. So if I went forward 7, it would be 5, 6, 7. So that's our standard power chord perfect fifth. But I could go backwards 5. So that would be right above it because there's 5 notes between the strings. So I could go here. So once again, I could see that it's an XD modal range, and I can call both of them a perfect fifth, which most guitarists will, but it's different because this one's going forward, and so I'd like to say this is a negative 5 perfect fifth, and this is a positive 7 perfect fifth, note away, and then I could go 17 back, which would be 5, 10, 11, 12, 13, 14, 15. I can't go 17 back from here. Dang it. Let's go 17 back from like, I don't know, this one. It would be 5, 10, 15, 16, 17. See, we can go 17 backwards. This distance, although it's still an XD, is different than this one. It's going in the negative direction. If I measure from the D to the X, I'm going to get a different measurement, right? If I measure from this D to this X, it's the 5 note forward, which would be a perfect fourth. But I'm looking at this as my center point. I'm measuring from here to there. There it's a 5 note negative distance, which is going to be a perfect fifth, not a perfect fourth. See, so we have to get that straight in our mind. The tools out there can be ambiguous. We don't like ambiguity. We want clear terminology. Language should be used to define reality. That's what we're trying to do here. We're trying to say stuff that's actually that helps us understand like what is happening. What if I go negative 18 back? The local distance would be 18 minus 12 or 8 minus 2, 8, 7, 6. So it would be 6 backwards. If I go 6 counterclockwise, then going clockwise would be 12 minus 6 or 6 forwards. This is the weird one. The 6 distance should tell me it's weird. not the fact that it's a diminished fifth or an augmented fourth. But I'd have to know it's a diminished fifth or augmented fourth. Therefore, the diminished fifth or augmented fourth could be basically 6 steps forward or 6 steps backwards. So that means I can also go backwards any octave of that. So -6 minus another 12 or minus an octave or it's a -18 diminished fifth. Now, note you can get kind of wonky. Is it a diminished fifth or an augmented fourth? I don't want to get into that right now, but that's the general idea. We won't get into the weeds on all that at this time. But in any case, the general idea, we're going back 6. So let's say we start in the middle again. So normally we think going forward, which would be 5. Well, the only one where that's going to land us, because this is the weird one, let's go with the crazy Locrian. If I start on the Locrian, that'll land us on a continent. So we go on the crazy Locrian, and we go up 5, 6. So that's an NY modal range, a 7-4 modal range. Or I could go backwards 6. So that would be -5, 6 here. Notice the pattern in this weird interval. So then we have, that would still be an NY modal range, but I would call that a -6 diminished fifth or augmented fourth. And then I could go back 18. Let's see if I can do that from here. 1 or 5, 10, 11, 12, 13, 14, 15, 16, 17, 18. So boom. So notice I need to be able to see that all 3 of those, I can call them a diminished fifth from the perspective of the Locrian, but they're different as well. How do I identify that they're different? Well, I can't use the diminished fifth because that's the scale degree as if I was going clockwise, which I had to use even though I'm going counterclockwise. So I can't really compound that too easily. So what am I going to do? I would recommend you say the notes, right? It's a negative. This is going directionality -18. This is directionality -6. This is directionality forward 6. Okay. Directionality is a thing. It is a thing. Okay? I'm sick of the lies. I'm sick of the lies trying to gaslight me. You could take your gas and use it to drive off. Okay. What if I go 19 back? So the local distance would be 19 minus 12 or 9 minus 2, 9, 8, 7. So that would be 7 back. If I go counterclockwise 7, going clockwise would be 12 minus 7 or 5 forward, which I would have to just know is a perfect fourth. Therefore, a perfect fourth could be 5 forward or -7 backwards. Or it could be -7 minus another octave, or -7 minus 12 perfect fourth, or a -19 perfect fourth. So let's say we start from let's go like this Aeolian. Let's do one on this side because I'm going to go further that way. And a perfect fourth is going to be 5 note away going this way. So it'd be 5 note away to here. It would be an AD modal range, in this case from the Aeolian mode. And then I could go -7, which would be 5, 6, 7. So it's still an AD modal range, but now I'm going in the negative direction from the perspective of this A. Again, I could measure from the D to the A, right? That would be a 7 note away forward, which would be a perfect fifth, but I'm going -7, right? A -7, which would be a perfect fourth from the perspective of this A, not the perspective of that D. But I could also go 19 back, which would be 5, 10, 11, 12, 13, 14, 15, 16, 17. I can't go 19 back from there. Let's go 19 back. Let's pick one like here. 19 back. This time, well, now I picked one under the fault line. I'd rather this fault line shifted up, so I'd have to go 5 back here, 5, 10, 15, 20, and then we're going back to 19. Okay, hopefully I got that right. But yeah, it's an AD modal range. That makes sense. So notice that all of these are I can call all of them a perfect fourth, and you might want to memorize them on the guitar so you can see the Aeolian to the Dorian is always what you can call a perfect fourth. But you want to get more sophisticated from that and be able to identify what that means and identify that these are all going to give you different sounds because it's not just a racetrack. We also have to add the dimension of time in our map analogy, right? We have directionality, forwards, backwards to get to each of the continents. To get from an A to a D, I go forwards and backwards, but I also have the time dimension that you have to, because it's different at any time. I don't know what I'm doing with the time dimension. I gotta work that one out. I'm working on it. It makes sense. I just haven't got the analogy perfect yet. Let me mull it over. What if I go back 20? If I go back 20, what's the local distance? 20 minus 12 would be like 10 minus 2, which would be 8. So 20 back would be 8 forward. So, I'm sorry, 20, it would be 8 back local distance. If I go 8 counterclockwise, 12 minus 8 would be 4 clockwise, which I just have to know is a major third. Therefore, a major third can be 4 forward or an 8 note back major third. And this time I'm going another octave back, so it would be 8 minus another 12 or 8 minus an octave or negative 20 major third. So it's a negative 20 major third. Let's say, let's start from like a Lydian over here this time and see if I have enough room to go backwards. So it's a major third. So if I go forward and it was a major third, it would be 4 forward. So this would be 5 going this way because we're crossing the fault line, and then it would be 5 going this way and then back to 4. So that would be a YA modal range or a 4-6 modal range. If I go backwards, I can go backwards 8. So in this one, I have a 5 note distance here because there's no fault line between those two. So 5, 6, 7, 8 in the negative direction gives me a YA modal range, which I can call a major third, but this is a negative 8 major third. Negative 20 would be like 5, 10, 15, 16, 17, 18, 19, 20. So now this one, if I go back, these are all what we can call major third distances, but I want to be able to distinguish them. And remember that if you don't use the letters, like if I call this an FA, then I could try to remember that if I go from the F to the A, then that's always going to be a major third. You can try to remember that, but that's going to be a lot more difficult because then you have to remember all of the relationships of 12 different notes. It'd be a lot easier to say, hey, look, whenever I do a YA modal range or a 4-6 modal range, then that is always a major third, right? That's going to be easier to memorize because usually you're working on the continent notes going from continent to continent. So you don't want to memorize. So if you memorize all the notes, then again, you could do that. That's a lot less efficient of a way to do it, right? You want to say, anytime I go to YA modal range, I'd like to start to just know that that's going to be a major third. But the major thirds are different, right? This one's a 4 note away major third. This is a negative 8 note away major third. This is a negative 20 note away major third. Okay, so then we're going to say, let's go back another one and say we're going to go back 21. So what's the local distance? If I go back 21, then we're not to 24 yet, so we haven't gone 2 octaves up. So it's still within 1 octave higher. So we're going to say 21 minus 12 would be like 21 minus 12 would be like 10 minus 2, 10, 9, 8. No, it'd be like 11. 11 minus 2. 11, 10, 9. So it would be 9 backwards. If I go 9 counterclockwise, that would be like 12 minus 9 or 3 clockwise. And I have to know that 3 notes away clockwise is a minor third. Therefore, a minor third could be going 3 forward or 9 backwards. By the way, once we get good at this, I no longer have to do the inverse. I no longer have to say, well, if I go 9 back, it's 3 forward. Once I memorize that the minor third could be going 3 forward or 9 back. Like I want to know it so well that I know that a minor third doesn't just mean 3 forward in the local distance. It means 3 forward or 9 back. Therefore, if I'm going past an octave, all I have to do is get it down to the 9, which I will then recognize if I go 9 back is a minor third. But for most people, we don't really recognize that. We only know the minor third as 3 forward. Therefore, we have to find the inverse and then go in the other direction. So I could say a -9 minor third, or a -9 minus an octave minor third, or a -9 minus 12 minor third, or a -21 minor third. So let's say we're going from a minor mode over here. We're gonna have to go way down. Let's go to the Aeolian down here, which is under the fault line. It's on the tectonic plate after the fault line. I use fault line here because of plate tectonics, and I'm in California, so I guess that's a. So, anyways, we could go forward a minor third, which would be 3 notes away. So this would be 5, 4, 3. So this would be an AI modal range, which is a minor third, 3 notes forward. Or I can go. Now, notice this one looks like it's behind it, but really it's going forward because there's 5 notes between here. So pitch-wise, it's still going up. 5, 4, 3. Now I want to go pitch-wise down. This tectonic plate shifted to the right. Therefore, I can't go straight up to have 5. I have to go left. So this is going to be 5 this way. So this is going to be 5. And then I can say -10. And then this is going to be 9. So I can say then this is an AI modal range, which is going to be a minor third. But now I want to go -21, right? So this was -9. So let's do that again. If this tectonic plate shifted this way, it would be 5, 10, 15, 20, and then 21. So now I've got, all of these are AI modal ranges, which would be great if I could just learn that every time I go from the Aeolian node to the Ionian node, or from the 6th node to the OneNote from a natural number system, it's going to be a minor third. But I'd also like to know that this is a 3 note away minor third. This is a -9 note away minor third, and this is a -21 note away, or a -9 minus an octave minor third. So that gives me directionality. And so, again, I think that's just objective. From what I can see, that is the best way to try to map all this stuff out. All right, let's go -22. So we're going to say it's -22. -22 minus 12 to get to the local distance would be like 22 minus 12, which would be like 10 minus 2, which would be 8, right? Oh no, which would be, I'm trying to get down to 10, would be 10. All right, I got my mental math is getting messed up here. I'm just gonna say it's 10, okay? All right. So then we're going to say, well, if I go 10 counterclockwise, what would be clockwise? It would be 12 minus 10, which would be 2. And if I know 2 forward, that would be a major second. So I have to then start to memorize that a major second could be 2 notes forward, or it could be 10 notes backwards, or it can be -10 minus another octave, or -10 minus 12 major second, or -10 or -22. So it's a -22 major second. Hopefully I'm not getting my majors and minors messed up again, which I probably have totally messed up. So beware that I might have got those mixed up. But we're going to say it's a major second, 2 note away major second. So if I'm on something, let's go way up here let's go to the Aeolian again. We're going to major second. So if I go major second, I could go from here to here. That would be an AN modal range, which has a 2 note away major second, or I can go -10 major second. So this fault line shifted to the right. So I go 5 here and then 10. So once again, that's an AN modal range, or a 6-7 modal range, but it's a -10 minor second, so, right? -10 distance. I'm going counterclockwise, and then I can go 22, which again would be -5, -10, 20. Oh wait. 10, 15, 20, 21, 22. So this up here is going to then be an AN modal range, but this is going to be a -22 major second, right? -20. So the AN modal range is always a major second, and you can memorize the shape, but I want to get more detailed and be able to say, now let me be able to count it out both in the positive direction and in the negative direction, which a lot of guitars aren't good at. We usually count things out from the top string and then count it down, right? And then we usually use the note names, which is a lot less efficient than using the continent names or the natural number system. It's going to be a lot easier. You'll go faster doing it more efficiently, I believe. There's no doubt. I mean, it's ridiculous. So if you go negative 23 distance, 23 minus 12 would be like 13 minus 2. 23 minus 12. Yeah, that's right. 13 minus 2, which would be 11. 11. I got that one. Why am I'm second guessing myself. So negative 11. If I go 11 counterclockwise, that would be 12 minus 11 would be 1 clockwise, which I know would be a minor second. So that means the minor second could be either 1 note forward or 11 notes backwards. Now the minor second isn't even in the Aeolian mode. It's in like the Phrygian mode. So let's go on over to the Phrygian mode over here. Let's see if I can pick one that maybe I have to go back. Let's try this one. It might not be able to go back that far. But let's say that we're going to say here, and if I go forward 1, it would be here. So that would be a PY modal range, which would have a 1 note away minor second. Or I can go backwards 11. So it would be 5 and then 10, 5, 10, 11 in the negative direction. Once again, a PY modal range, but now we're going in the negative, so it's a negative 11 minor second. Or I can go negative 11 minus an octave, negative 11 minus 12, or a negative 23 minor second. Can I get there from here? I'm doubting it. It's going to be 5, 10, 15, 16, 17, 18, 19, 20, 21, 22, 23. No, I could totally do it. I could totally do it. So that's still no, wait a sec. That's not right. Hold on. Yeah, no, that's right. I'm getting tired. So this is still a PY modal range, but this is a negative 23 minor second. Okay, so that's the general idea. Now, the same principle, I won't go through all of them, but if we went back 2 octaves, you'd have a similar kind of thing, right? So if I went back 24, noting that you're not going to go back that far all the time, but you could possibly go, on the guitar back that far. On the piano, it's going to happen, more often because you might have more directionality. Maybe, I don't know. So yeah, you think so. That's true. So then we could go back 24, which would be 24 minus 12 minus 12, or 24 shows you that you've gone up or in the negative direction 2 octaves, because now you've gone 12 plus 12 is 24. So now you know that you're going to have to subtract 12 minus 12 or 24 from it, which would bring you back to the perfect first. If you went up to 25, then once again you'd have to know that you've passed 24 distance-wise. So then that means there's 2 octaves in the negative direction. So I'd have to subtract not 12, but 12 minus 12 and 12, or 24. So that would be equivalent to going negative 1 backwards, right? Be equivalent to going negative 12 or negative 1 backwards, which would be a major 7. So this is going to be a negative 25 major 7. If I went back 26, I'd have to say 26 minus 24 is 6 minus 4, which is going to be 2. So that would be equivalent to going 2 backwards, which would be like going 10 forwards. So it would be a negative 2 minor 7. And this would then be a negative 26 minor 7. So negative 27 minus 24 is like 7 minus 4. 4, 5, 6, 7 would be negative 3. So that would be like a negative 3. If I went 3 back, that would be 12 minus 3, 9 forward, 9 note away, major 6. So we can also have a negative 3 note away, major 6. And we can also then have a negative 27 note away, major 6, and so on and so forth. Now you can see the problem with this, of course, is that this second term is not really helping us that much, although it does kind of give us the flavor. And once we add the note names, we can totally use that, and we can not allow the terminology to get us messed up. So notice that this is one reason, however, I think the compound interval thing, where we go forward and we use a compound interval, is not the optimal thing to use, because it falls apart going backwards. So I would recommend the optimal thing to use is to have the distance notation either in notes or the local distance plus and minus the octaves. The local distance, positive or negative, plus or minus an octave, is the term I think would be best to use. But of course, I think it would be better to use the terms that we'll go into next time for modal distance. So I would highly recommend, even if using this system, you still think about the modal ranges, because then you can start to memorize. It won't take that long if you see what you're doing, that you can memorize all of the different combinations of the modal ranges, and then know all of the 7 local intervals that you can have, right? And that will be very nice to be able to know. But again, I would like to be able to have a more efficient system where I can go forwards and backwards and see the difference of going forward and backwards more clearly, both in the notes as well as the modal distance. So I can actually count out both the modal distance as well as the note distance. That's what we'll get into next time.